Hey guys, so today we're going to talk about lesson 8-5, solving equations by factoring. So before break we had talked about solving equations using the factoring by grouping strategy. We did talk about factoring out GCMFs and then doing the factoring by grouping. So we're going to continue that, and then on Thursday we will have notes on how to do any kind of factoring, okay? Solving equations by factoring. So I'm just going to give today's date, which is 4/20/2020. Okay, so we've got a property we need to understand, and it's called the zero product property. So property just means rule. So this is rule about multiplying with zero, okay? Product means the answer to multiplication problem. So it says if the product of two or more factors equals 0, then at least one factor must equal 0. Okay, so in true algebra fashion, if the product of two or more factors equals 0, then at least one factor, A, can equal 0, or the factor B could equal 0, or both. A and B equal 0, both factors can equal 0, okay? So how are we going to go about solving this problem? Okay, so first thing, we're going to get the polynomial on one side. And then, of course, remember, you want to go ahead and do, I'm jumping the gun here. Let me, I don't like the way that I wrote that one. Just one. On one side, and a 0 on the other side. Okay, now how do you do that? You're going to use inverse operations, right? And you're going to do it term by term. Inverse meaning if it's an adding, you're going to do subtracting. If it's a subtracting, you're going to do adding, and so on and so forth. Now, key here is put the order in descending degree order. That's how we need to do setups anytime we're going to do factoring. Okay. Then the second thing we're going to do is factor the polynomial. So we're going to look for a GCMF first and foremost. Greatest common monomial factor, so it could be just numbers, it could be just variables, it could be a product of numbers and variables. And then look to see if you can factor by grouping, okay? These are the things that we know to do at this juncture, okay? And then we're going to set each factor equal to 0, because we don't know which one it could be, so we have to test both of them. And solve for the variable. Didn't like how I wrote that, sorry. So what this means is that we could have more than one correct answer. And then we're going to write the solutions. Because there's going to be more than one answer, most likely. In what's called solution set notation. We've talked about this guy before. Anytime you have more than one answer, you're going to go ahead and have braces, and then you'll have a number, and then you'll have a number separated by a comma, and we'll close up the braces. Okay. Okay, so we're going to do a diagram, and then we'll be doing some examples on our next page. You probably can get the first two examples on the same first page, but I'm going to run out of room. So I want to talk a little bit about equations that are of the second degree. Okay, so that means the highest exponent is a 2. So that guy is called a parabola. That's the graph. So it's the graph of a quadratic equation. And that's really the big thing that we study here. Algebra 2, you get to study equations where you have the highest degree is a 3. Okay. The graph of a quadratic equation, something that's like x squared plus 3x plus 2, where it has a degree equal to 2. So the highest degree, so we go by the highest degree, names that the degree for the equation. So the highest degree is a 2, okay? So the parabola is the graph I get. And again, that's what we focus our studying on in algebra. Now, there are 3 ways a parabola how many solutions a parabola can have, or a quadratic equation. So the 3 different ways the parabola will look. So one way, which is the most common one, so I'm going to keep him black, is when I'm looking for the solution of a quadratic equation, I'm trying to figure out what its x values, its roots, its solutions are. So where it crosses the x-axis, that's what I typically am going to get, is the x-intercepts roots, solutions. Okay, these guys, parabola generally speaking crosses the x-axis in 2 locations. So this is most common. Two solutions, most common. So that's what you expect to get is 2 answers when we're doing parabolas. Sometimes we can get 3 when we've got a quadratic equation. No. That's if I have something else. Never mind. Scratch that idea. Okay, so what's a different thing that could happen? Well, a different one is that your parabola can just touch down at exactly 1 point. So in this case, there's going to be only one x-intercept. In this particular case, it's the point 0, 0, but that parabola can shift right or left depending on other things going on in that problem. And then we've got this weird guy. And he's just I call him a floater. And notice he doesn't touch the x-axis whatsoever. So we would have no x-intercept. Okay, so that means there is no solution to this one. Okay. All right, so those are going to be the common ones. And I'm going to go to my next screen to start doing some practice. Okay. So let's start with solve each equation. So we're going to go from easiest to hardest. And then check your solution or solutions. Okay. So we have, and what makes these easiest is that they already have already been factored for you. So we have 2d plus 6, quantity times the quantity 3d minus 15 equals 0. So as long as I have only something times something, and it doesn't matter if there's more terms inside of the polynomials, that's what are in the parentheses. So according to what we're going to do is we're going to take each factor and we're going to set it equal to 0. So we're going to do the 2d plus 6 equals 0. Actually, let's change him up. Let's change a little. We'll do a little color on that. Equals 0, and then we're going to take the 3d minus 15 and set that equal to 0. So then we're just going to do inverse operations to solve. On this one, I would subtract 6 from both sides. On this one, I would add 15 to both sides. That gives me 2d equals negative 6, and 3d equals 15. Continuing on, the inverse of multiplying by 2 would be dividing by 2, and multiplying by 3 would be dividing by 3. So 2 divided by 2 is d, and then negative 6 divided by 2 is negative 3, and then we have 3 divided by 3 is 1 times d is d, and 15 divided by 3 is 5. Okay? So what we can do is double check and make sure if one of those factors equals 0, then the product will equal 0. So if we checked it, if we did 2 times negative 3 plus 6 times the quantity 3 times negative 3 minus 15, and the question is, does that equal 0? So I get negative 6 plus 6 times negative 9 minus 15 equals 0. So that gives me 0 times negative 24 equals 0, and that works. So that says, yep, I agree with that guy. And then we've got 2 times 5 plus 6 times the quantity 3 times 5 minus 15. Does that equal 0? So we get 10 plus 6 times 15, take away 15. Does that equal 0? So then we get 16 times 0. And we get 0 equals 0. So what that says is that the d can equal 5. So your answer, or your roots, or y-intercepts, are the quantity, or the solution set, that contains negative 3 and positive 5. Okay? All right, next one. We've got 3n times the quantity n plus 2. So this one had a GCMF. So again, there's two factors here. So we're going to take the 3n and we're going to set it equal to 0. And then we're going to take the n plus 2 and we're going to set it equal to 0. So on the first one, the inverse operation would be to divide both sides by 3. And on the second equation, the inverse operation would be subtracting 2 from both sides. So this would give me n is equal to 0, and n is equal to negative 2. Okay, so then we can check those. And we get 3 times 0 times the quantity 0 plus 2, and would that equal 0? So I get 0 times 2 equals 0, so 0 times 2 is 0, and I get 0 equals 0. So that what that says is, yep, n could equal 0. And then the second one, we would have 3 times negative 2 times the quantity negative 2 plus 2, and does that equal 0? So that would give me negative 6 times 0, and I get 0 equals 0. So that verifies that negative 2 is. So we could say the answer is the x-intercepts are 0 and negative, oh, sorry, I don't need to put the word and, negative 2. So this would be the x-intercepts are the solution set of 0 and negative 2. Okay, so I'm going to do a third one here. And again, if you need to be on your next page, go for it. I'm going to be going on to one more screen after this one. So now they get a little harder, and they're not factored necessarily, but they've got the polynomial on the left side in descending degree order and the constant on, or 0 on the right. So now we need to factor. So I'm going to look for something that can go into both 4x and 8, and that's going to be 4. So I'm going to factor out the 4. That doesn't mean throw it away, it just is out there. So 4 divided by 4 is 1, 1 times x is x, and 8 divided by 4 is 2. So we're going to take each one of those and we're going to set them equal to 0. So we're going to have 4 and set it equal to 0. And then we're going to have x plus 2 and set it equal to 0. Oops. Change my color. And the first thing you might notice is, wait a second, 4 doesn't equal 0, so 4 is not a solution, right? Because we're solving for the variables. So on this guy, we're going to do inverse operations, and we get x equals 2. So this is an example of that parabola where it just touched down at negative 2 on the x-axis. And that's it. And the parabola was facing upwards from there, and we didn't have any other possible solutions. So we can test this. And we get, is 4 times negative 2 plus 8 actually equal to 0? And we get negative 8 plus 8 equals 0, and we get 0 equals 0. So what that tells us is the answer is negative 2. So then we could say something like the solution. Now notice I'm using different words because they all mean the same thing. The solution. Now this time I don't use the solution set. Why not? There's only one answer. The solution is negative 2. Okay, let me box all of these. All right, so I'm going to go to the next screen, which would be officially the next page. So I'm going to relabel it as Lesson 8-5, Solving Equations by Factoring. And we're still on 420. And we are still following the same directions. Solve each equation. Check your solution or solutions. Now I know I'm going to hear complaints. Why do I need to check? And the answer is, who do you want to figure it out? Me or you? If you figure it out, then you can correct it before I look at it. But if I figure it out, yeah, okay. So we have 8b squared minus 40b equals 0. So again, just like the last one, everything's, the polynomial's on the left, 0's on the right, the polynomial's written in descending degree order. So now what I'm going to do is look for something that goes into both of those. So let's see, between 8 and 40, oh, I could pull out an 8. 8 goes evenly into both of them. How about b squared and b? I'm limited to the smallest amount of the variable. So my GCMF is 8b, and what do I have left? So 8 divided by 8 is 1, b squared divided by b is b, and then minus 40 divided by 8 is 5, and b divided by b is 1, so that's it. Okay, Now I'm going to take each one of these and I'm going to set them equal to 0. So we have 8b is equal to 0. And then we've got b minus 5 is equal to 0. So on the first one, I'm going to inverse operation would be to divide both sides by 8. In the second one, the inverse operation would be to add 5 to both sides. So this gives me b is equal to anything divided, 0 divided by anything is 0, and 0 plus 5 is 5. So I'm going to check. Oh, did you hear that? That's my stomach. Yikes. 8 times 0 squared minus 40 times 0. Does that equal 0? So we have 8 times 0 minus 40 times 0 is 0. Sorry, question mark. And then we get 0 minus 0 equals 0. That's true. So 0 works. And let's try 5. 8 times 5 squared minus 40 times 5. And is that going to equal 0? So we have 8 times 25 minus 200 equals 0. So that's going to give me 40, 16, and 4 is 20. So I get 200 minus 200 is 0. And yep, that works. So that means the 5 is correct. So my answer, the roots are the solution set that contains 0 and 5. So remember, you're always going back up to the solutions we got. All right, now we're going to get into the most complicated. That means we've got terms on both sides of the equals, and we may have to factor, okay? So we got c squared equals 3c. So job 1 is to get all the terms on the left, 0 on the right, and make sure that when I write what's on the left, I do it in descending degree order. So I get c squared minus 3c equals 0. Now I look for something that they both have in common. It's not a coefficient, so let's see, I'm limited to a 1c. So I factor out c, and that gives me c squared divided by c is c, minus 3c divided by c is 3. Take each one of those and set them equal to 0. So I get c is equal to 0. That looks like e, doesn't it? Oh well. And then c minus 3 equals 0. So the first one's already solved, c equals 0. Okay, so 0 is one of the solutions. So I'll just rewrite that. The other guy I have to do a little bit of work on. I'm going to do inverse operations. I'm going to add 3 to both sides, and I get c equals 3. So I'm going to go ahead and check. Now you could do the check visually, okay? That means you don't have to necessarily equals 3 times 0. You don't necessarily have to do them out. You could do it in your head, but remember, sometimes in your head you make mistakes. I get 0 equals 0. That's true, so that says 0 is a solution. And the next one, we've got 3 squared equals 3 times 3. Oops. Yeah, and I get 9 equals 9. So that verifies that c can equal 3. So on this one, the x-intercepts are 0 and 3. And last example, we've got x squared equals negative 10x. So again, same problem as number 5. I need to get everything on the left. So the inverse of negative 10 is a positive 10, so I'm going to add 10x to both sides. Writing in descending degree order, I get x squared plus 10x equals 0. And then I'm going to see if I can factor. Let's see, no coefficients, but they do have one x in common. So I get x, and x squared divided by x is x, and then plus, and 10x divided by x is 10. I'm going to take each one of those, set them equal to 0, and solve. Okay, so first one I'm already done, so I get x equals 0 as one solution, and then on the other guy, I'm going to do inverse. I'm going to subtract 10 from both sides, and I get x equals negative 10. So then I'm going to check, and I always go back to the original problem. Is 0 squared equal to, I forgot to put that there, bink, bink. Is 0 squared equal to negative 10 times 0? And we get 0 is equal to 0. That works, so 0 is the solution. And then we're going to have negative 10 squared. Does that equal negative 10 times negative 10? So a negative squared is going to be a positive. 10 squared is 100. Negative times a negative is a positive. 10 times 10 is 100. That's true, so that means that x can equal negative 10. So the solutions are the set that contains 0 and negative 10. Now, just to let you know, when it comes time to writing down answers, you're not going to write out the words so much unless it's a word problem. You would just write the solution set of 10 and negative 10 in the answer column. So it just braces, 0, comma, negative 10, braces. All right, there you go, guys. Good luck.